Dear ladies and gentlemen, today I am presenting you a vibrometer made by Association VAST. This is vibrometer CM-21. This is a small pocket-sized device that is very convenient. It is IP65, so you can wash it on the water. It is certified to work from -20 centigrade, and the operation time from battery is about 10 hours. So if you compare it to a standard vibration analyzer that I have here, this is vibration analyzer DC23, you can see the difference in size, but still this small instrument is a quite powerful device for condition monitoring and vibration analysis. It can measure vibration, it can measure temperature, it can measure rotation speed and some other parameters. So to do the vibration measurement, first we can do the setup. We go to the menu, select the setup, and what we can set up is the bandpass filter first. So we enter the bandpass filter setup. We have low frequency range, we have high frequency range. We can measure simultaneously low and high frequency. Additionally, we have some special ranges for bearing diagnostics or for some other analysis. If we consider the low range, the low frequency range, there are two standard frequency bands from 2 Hz to 1 kHz and from 10 Hz to 1 kHz. These are the two standard ranges that are used by the standard, by ISO standard 10816. For example, from 2 Hz we measure on slow rotating machines, rotating below 600 RPM or 10 Hz, and after 10 Hz we measure all other machines that are rotating above 600 Hz. Additionally, if you have some frequencies in your machine like gear mesh or blade pass frequencies for turbines that are higher than 1 kHz, you can add a few bands in the filter, up to 2 kHz or 5 kHz. This is also required by the ISO standard that says if you have vibrational higher frequencies, some main frequencies above 1 kHz, you should increase the frequency range for your analysis. If we consider the high frequency range, then we measure up to 25 kHz. So this is actually an instrument that can measure frequencies up to 25 kHz and do also shock pulse analysis. And the ranges are from 6, from 10 and from 15 kHz up to 25 kHz. Typically used for the bearing diagnostics. So we can also make simultaneous measurements on low and high frequency. The other thing that we can do is the magnitude value. We can choose the magnitude value. For acceleration, the choice is between RMS, peak, 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 and the same you can change for, you can try for velocity. You can set for velocity displacement. For example, for acceleration we can set RMS, for displacement we can set peak, and for velocity we can set peak, and for displacement peak peak. This is quite a typical American standard. If we go for ISO standard, all of them requires to be RMS. So we can set everything to RMS. Next, what we can do the alarming. So in this instrument you can program alarm levels. For example, we enter it and we can set separately alarms for acceleration low frequency, high frequency, for acceleration peak factor, for velocity and for displacement. For example, here I will measure velocity and I set the alarm levels for velocity only. Low alarm, alert and danger. For example, right now for low I have 1 mm per second and I will consider that my machine is not working. For alert, I have set 4 mm per second. Of course, I can add it, like put, for example, 6 here, or 5. And for danger, right now, I set 13 mm per second. I can also decrease it a little bit, for example, down to 11. So, this is alarm levels, back, and now we are ready to start the measurements. So, to make measurements, we just press record, and the instrument will continuously make measurements of acceleration, velocity and displacement. Now it says that we do not have any sensor. Okay. We supply a sensor like this with this instrument. This is a standard ICP or EEP sensor, and we can connect it to the sensor. I'll line the red dots, and here is the connection. Now we can use some handheld probe, for example like this, and we attach it, and now we are ready to do the measurements. So what can I do is I will switch on my machine. So I'm switching my machine like this, and we have some vibration signal. So we take our handheld probe and point it, so I'm not reproducing some alarm because I'm not very accurate with the sensor. We point it to the machine like this. When we point it to the machine, we get the reading and we can save it. So we can just look at it. So here we have acceleration 7 meters per second square, we have velocity at about 2 millimeters per second, and we have displacement of about 5.9 microns. We can save it in a point. You see that now it is machine 9.4 horizontal. So we can change the machine like 9, 10, 11. You can use any cell for storing it. We can change the point, 0.2, 3, 4, etc. And also we can say the direction. For example, right now I made it vertical, so we can say it machine 12.7 vertical, save. So this is quite easy, and in this way you can save these these points, this data in very many points. It's up to about 1,000 points that you can save. The other interesting feature of this instrument is that you can listen to vibration. You can use it as a stethoscope. For this purpose we have an earphones here. This is quite a good earphones, industrial and noise proof. So we connect it to the instrument like this. And to show you how it works, I will do the following. I will take my microphone, will start my machine, and I will put microphone inside the earphones. So we can listen just to a machine normally, like this. You see that it's more or less the same, everything is the same, the noise doesn't change. But then we do the following, we put it inside the earphone. So I think that you can guess what is condition of the bearings and the motors, etc. I can tell you that here I have a bad bearing with a defect of outer race. So by the analysis of the sound from this machine, you can also do the analysis of the machine condition. Feel yourself like a doctor with a stethoscope. So actually this is a stethoscope, and in more scientific or engineering way it is called the acoustic method of non-destructive testing. So you can do this. So I remove the earphones and we continue with different features of our instrument. It is important to note that with this kind of probe you can measure only low frequency vibration, because the high frequency vibration will not penetrate through this needle. For the high frequency measurements and for the data collection, actually we recommend a magnet, and we supply a magnet like this. We will usually add some grease to the thread so that the high frequency vibration will penetrate to the sensor. It's like when you go to the doctor for the ultrasound inspection. The doctor applies some grease on the sensor so that the ultrasound will go to your body and from your body to the sensor and vice versa. So using this magnet we can make high frequency measurements, and what we do, we can apply this sensor. For example, we have machine 12.7 and it is in horizontal direction. So we put it in horizontal direction, we start measurement, we press record, here we get the reading and we can save it, yes. And then we go to axial direction. In axial direction you put the sensor in corresponding way and you make the reading. So you see that we have very high vibration in axial direction for this machine, and we have alarm. We have alarm, we can save it with alarm, yes. And now it is vertical direction. We can also change it. For example, we can change the measurement point. We can change the measurement point. We can change the measurement point to vertical. With record. Yes, vertical. Record to date. In vertical we have quite a good vibration. It's only 1.5. We save it. Yes. So this is the way how we do the vibration data collection from scratch, without any roots or something like this. Also, we should note that this instrument has a possibility to make measurements according to the root. So we have a root here, and we can set up the root in the software that is supplied with this instrument. Working with the roots and with this software we have additional video, so stay tuned to our channel and you will see how vibrometer CM-21 works with vibro level software and makes measurements according to the root. But in this video we will continue the general overview of the instrument. One more feature of this instrument is temperature measurements. So when we go to any vibration measurements, we have a temperature sensor somewhere here on the instrument. It's a pyrometer, and even without a vibration sensor we can measure the temperature. So now in my room we have something like 24 centigrade. The motor is a little bit hotter, so if we put it next to the instrument we have 30 centigrade. If I put my hand here it will be something like, yes, something like 32, 33 centigrade, depending on the point where I use the measurement. We can do it a little bit faster. We have a special temperature measurement mode, and then when you will just put your hand it will make measurements very fastly. Also we can find the place in the machine that is the most hot. For example, we do like this and record that, yes, we have something like 31 centigrade somewhere here. So somewhere here is the most hot part of this motor. With this function you can test, for example, electrical connectors and find the electrical connectors that have some problems in contacts. So this is the feature of temperature measurement. The other feature is the rotation speed measurement. We can measure rotation speed of the machine, and for this we have two types of sensors. One sensor is the infrared sensor, like this. The infrared sensor is quite good, and it can measure rotation speed usually on most shafts, even without a mark. So if I consider my shaft here, I don't have any mark here, and I can rotate the machine. I connect the sensor like this, and I will try to make measurements on the shaft. So I put it next to the shaft like this. Sorry, I need to find some position with my hand. Like this. And this is the rotation speed of my 3000 RPM machine. I can release the load and it will be a little bit faster. You see that it's a little bit faster. So this is the rotation speed of my machine. I can apply more load and it will be a little bit slower. For the induction motor it's quite typical, we have a sliding frequency. So this is the rotation speed measurement with a sensor like this. The distance at which it works, it's a few centimeters. It's from about maybe 2 centimeters up to maybe 10 centimeters with this very sensor. The other sensor that we use, it's a laser sensor. The laser sensor I have here, like this. It has a laser inside and we can connect it instead, like here. And we have a laser beam. And if we start measurements, we point to the shaft and we get nothing. This is quite typical for a laser sensor. It will not work without a mark. Okay, let's stop our machine. And I have some mark here. And I will just glue this mark on the shaft. This is reflective mark. I will glue it on the shaft. I start my machine and I point with my sensor somewhere here. Yes, I get the rotation speed reading. So this sensor can work from a very big distance, up to about 2 meters, like this. I can even go with it much far, like this. This is about 1 meter now. We can measure it up to 2 meters. Again, if I release it, it will be a little bit faster, like this. As you see, it's a little bit faster. And it can work also from some small distance, a few centimeters as well. So the difference between the two sensors that we use now is that laser sensor is much more stable, but it needs the mark. The photo infrared sensor, it may not need any mark. Of course it will work with the mark, but just if you don't have any mark on the shaft, in most cases, in 99% cases, it will do the measurement even without a mark. So this was a brief overview of the CM-21 vibration meter and data collector that is produced by the Association VAST in St. Petersburg, Russia. And stay tuned to our channel. We have the next video that is devoted to the root operation of this vibrometer. Thank you very much for your attention. Welcome back.